All right, then let's start off. Hello and welcome everybody to the session Considerations of a Practical Migration to Cloud Foundry. My name is Matthias Braach and I'm joined by Alon Aizenberg. We are both working at SAP in different projects and have both just recently migrated our software stack to Cloud Foundry. And in this session, we want to share our experience we made, how we achieved a quick migration and successful migration, and we'll talk about what application adaptation we have done, and also what temptations we try to resist so that we have overall a good migration in place and could really easily migrate everything to Cloud Foundry. To get this started, maybe to get some feedback from you guys, I would like to do a little poll. So who is currently from you guys migrating software to Cloud Foundry? Can you just please raise your hand? Oh, okay, already a couple. So who's considering to move to Cloud Foundry? Okay, also some. And is somebody already working on Cloud Foundry? Okay, cool. So the session will be definitely of interest for all of you guys. We talk about different parts and have a look at the agenda today. So we will start off with application adaptation. So what we recommend to do to make your application ready for Cloud Foundry, and also talk about resisting temptations, so not to do everything at first. We'll come to that later. The second part is the actual migration execution, so how you can achieve a quick migration and a successful migration. After that, we will have a look at how you can efficiently use the platform in the end, and see about what services there are and what you should start doing at first. And at the very end, we will have a look at the cultural perspective of such a migration, because if you've not been on a PaaS before, this will most likely be a big hit for the team, but a very positive hit. So, and that's why we will have a look at what changes there will be. So before we get started, some information about SAP itself. So I think you all know SAP is one of the worldwide leader of business software. In the past years, we have heavily invested into cloud and still ongoing. So we have our own Cloud Foundry offering in place. It's called the sub-cloud platform Cloud Foundry. And the cool thing here is we have a multi-vendor support, so you can pick the underlying IaaS, you can be on AWS, you can be on Azure, SAP's own data centers. So we leave that free for you to choose. And yeah, we have already over 10K customers on board. So if you're interested, just visit cloudplatform.sub.com. Good, and with this, I would like to hand over to Alon. So Alon, what made us change to Cloud Foundry?
Awesome, thank you, Matthias. So yeah, before talking about the actual changes that you will need to do to your applications to successfully run them on Cloud Foundry, let's talk about why we choose to go with Cloud Foundry. So historically, we were running our application stacks and the components and services on an in-house infrastructure as a service provider. With that, obviously having quite a large invest in things like infrastructure provisioning, infrastructure automation, deployment automation. So all of those things were putting quite a lot of effort on our teams. Moreover, we were using quite a lot of unmanaged services, if it's the backing services like databases that we were using, but also all the stack that we're using for the development, so things like continuous integration, continuous delivery, infrastructure, log management, monitoring, you name it. All of it we were running ourselves or with some additional teams at SAP helping to do that. So we were really looking to simplify what we are doing, simplify the amount of the tools that we need to manage, and we were looking to boost the development experience and the development productivity. So choosing Cloud Foundry really allows us to focus mostly on the important thing that we are doing, so writing and building software. So we could completely get rid of all the infrastructure hassle by just using Cloud Foundry, which basically substitutes all the hassle around infrastructure, provisioning, and automation, and including also the deployment automation as well. So let's talk about the actual application changes. So you have an application that runs on some other platform and you want to migrate it into Cloud Foundry. Before talking about that, let's quote the Agile Manifesto here, which says that simplicity is essential. So applying that to the migration process, means that you really want to break down your set of applications instead of deploying everything together and migrating everything together into Cloud Foundry. You should really look into your application stack, look into each application and see which components it is built from, and choose the one component which is less critical and a component that you really can migrate first. And we propose to first migrate that component, learn everything you need to learn on the fly, so do not waste months and months into learning Cloud Foundry and learning all the surrounding technologies. You just take one component and you learn on the fly how to use Cloud Foundry and how to deploy productively that component. And this means also learning how to build CI and CD around the platform, how to do the monitoring right, how to do the metrics collection, operations, everything. So once you did that for a simple and non-critical component, it will be super easy for you to repeat the process for the rest of your stack. So for the rest of the components. So yeah, this is the proposed way. Another thing to consider is that there might be some components or even whole applications that you do not want to migrate at all. So an example might be application which is very difficult to migrate because it will require a lot of changes. We will see later which changes you might need to do. But also the lifespan of the application. So if you have an application which is quite complex to migrate and it's going to be retired in 1 year, maybe it doesn't worth the effort of migrating it. So the next thing to talk about is resisting temptations. So it is very easy to mix into the migration process refactoring, right? So you have application which runs in production for some time. Every team has that, and every team in such applications needs to refactor stuff. And it sounds very reasonable to mix the refactoring that you want to do together with the migration. When you look into the Cloud Foundry first, you see, okay, cool, this supports native containers, it's polyglot, so I can develop in any language I want. It's very easy to deploy. It's awesome for microservices, so maybe I will refactor my monolith into microservices. Let's do it together with the migration. So this is a very bad idea. You want actually to change the minimal amount of application code lines that you have to. And we will speak in a second what you have to really change. These things are awesome. If you need them, you should plan to do them after the migration. So if you decide together with your teams that you need to break a monolith into microservices, you should do that after the migration, not together with the migration, because it will just complicate everything. So let's talk about the actual application changes that you have to do, right? So to understand which application changes you have to do, we need to understand what Cloud Foundry is, or actually any PaaS. So a Cloud Foundry is, in the end, an orchestration engine. And that means that it takes your application, it takes the configuration of that application, and it monitors the application in production. And it can decide, based on the configuration and based on the traffic even, if some of the instances of application should be restarted, maybe they should be completely dropped, maybe you have a component which monitors the traffic and scales up the application automatically and scales it down. And that means that your instances might be shut down without any further notice. So you have to build the application to be resilient, and there is a very awesome thing to build your application around the 12-factor app manifesto. This is 12 properties for cloud-native applications, and 4 of these presented here are really essential for a successful application running on cloud-native platforms such as Cloud Foundry. So the first one is, of course, statelessness. If you have a state in the application, and now the platform decides to cut the instance that holds the state, the user loses the session. So you have to be stateless. This is the first thing. Then you really need to separate between the backing services and the application instances, which means that the lifecycle of the application should be separate than things like databases and message queues and any persistent service. Because services will come and go, and they need to be able to quickly attach to an existing backend and detach from an existing backend. The next property is disposability, very important. It's actually 2 properties. One is quick startups, and the other one is graceful shutdowns. So the quick startups is important because when the platform is spinning up new instances, you want your instances to be quickly up. Otherwise, you might get into a situation of a downtime, so the application is monitored and something is not wrong with some of the instances, and new instances has to be started up very quickly. Disposability is also, as I said, graceful shutdowns, and this is to prevent data loss. If you have a transaction in the middle or a request processing in the middle and then the instance is down, you lose data and you lose state. So you have to the containers or the instances have to be disposable, and configuration via environment. So Cloud Foundry loads all the configuration into environment variables. So your application has to support loading configuration from environment variables. There is a big debate now on the internet, should you really store configuration in environment, especially secrets, but that's maybe for a different session. Awesome, let's take a look into a few examples of applications or components that we migrated. So the first one is a static application built with the AngularJS static web app. Very easy to migrate, so using the static file build pack, which is essentially an Nginx, where you deploy your static files there. Very easy, 0 changes to the application. We got completely removed all the hassle around VM provisioning, around deploying the web server, deploying the application, so all of that is not needed anymore. You have CF push, you push the application as is, it works. Awesome. The next example is a Java application. Our API is written with Spring Boot, and this is important. So if you are using a framework for your applications, which is already cloud native or cloud aware, it will be significantly easier for you to do the changes that we were talking about. Right, so Spring Boot supports things like configuration you can load from anywhere you want by very little effort. So for us, migrating this application was very simple because we were already on the correct framework. With really a few simple changes of configuration, for example, how the logs are generated and formatted, because we were now putting the logs into a managed service, into Elasticsearch managed service. So really small changes to log4j configuration and additional configuration files, and then the application is migrated as is, and again, a big win in all the things that are related to provisioning and deployment automation and infrastructure management. Another example is an example how awesome managed services are. So we have a component which schedules jobs on a bunch of VMs, and the previous infrastructure we were using didn't have a native scheduler, so we had to use Rundeck, which is an open source scheduling software, and we had to pre-provision the VMs on which we were running the jobs, and obviously the automating that stuff was very complicated. So the Rundeck, for example, we have, it has users, and we need to provision the users, and we need to provision the jobs, and we need to provision the VMs, a lot of effort. On Cloud Foundry, we're just using the CF native scheduler, which then uses CF tasks, which spawn new instances on demand when the jobs are running. In that case, this is a Node.js application, so this runs on the vanilla Node.js build pack very easily. We save all the hassle around the infrastructure provisioning and automation, and of course, we are saving costs because we do not have to pre-provision the VM. The instances are started, the jobs are executed, and then the instances are shut down, and we do not have to pay for them. So these are a few examples of applications that were very easy to change or very, very easy to migrate. But of course, there are also some use cases where the migration is quite difficult, and it might happen if your application, for example, relies on services that you had in the previous infrastructure or platform. You do not have them on Cloud Foundry. And in that case, there are different solutions. They are more complex, like having abstraction layers and so on. Matthias here has experience with applications like that. Maybe in the Q&A session, if there is a demand to talk about this topic, Matthias can elaborate on that. Okay, so the next thing is, so we understand which properties of the application we need to have for the application to smoothly run on Cloud Foundry. Let's talk about how to execute the migration. What is the best way to execute the migration? And here we will quote again the Agile Manifesto, which says that you should be preferring basically releasing your software frequently, and you should, of course, prefer the shorter timescales. And when we apply that to a migration process, we basically understand first of all, why this is important for a migration process to be quick. So a migration is quite a stressful time for the team. So not only your team now is busy with doing the migration, learning new technology, learning new tools, it also has a productive system running because you're migrating here a productive application. And obviously you have bug fixes, you have new features running, you have the business, and you have the operations of the system. So you have downtimes, you need to investigate what's going on. You don't want to have this process very long. You want your team to go back to your normal route where they need to handle the stuff that they're handling, right? So how to do that? The first thing, and I think this is the most important thing to understand, is that you really want to have one code line, one artifact, and you deploy that artifact to your prod and to the new platform. At first, when you think about it, it might sound logical to fork the code because you have an application instance running on the old infrastructure, and now you have also a new infrastructure which has different properties. So you need to do some code changes in some cases. How do you do that? So yeah, maybe we will just fork the code, but this is of course a very bad idea. Then you have two code lines, you have double the maintenance and the stress, and even the team might be forked because some people will be dealing with the old code line and some people will be dealing with new code line. It's not something you want to get into. So you need to do everything in your power not to fork the code. And then the benefit of this is that you deploy exactly the same artifact. So you build the artifact only once, and then you deploy it to the old infrastructure and to the new infrastructure. You run all your test automation against both, and then in the end you have two productive systems running exactly the same version, which has many benefits. And the first benefit is that it is very easy to understand where the problems are, right? So if you have your application running on your production and it works fine, and on the new platform you have issues, and the binary is the same binary, cool, so it's easier to identify or to isolate the problem. But also you have, of course, the benefit of switching from one environment to the other one. So let's say you went live and now you have issues. It's very easy to go back. Of course, there is the data problem into which databases you're writing, but let's put this to the side. Having this is super important. All right. So how to decide when your application is ready? The good thing is that you have a productive environment, which is a very big benefit. So when you think about it, when you're writing a new application and you have no clue how this application is going to be used in production, what the user is going to do, how many users you will have, you don't have any numbers. It's more difficult than just looking into a productive system. You know what's the usage, you know what's the data, you know what are the peak times. So you just copy the data and you run load tests which simulate the same behavior that you have in production on the new platform. Not only regular load, you can also run severe load, severe stress to understand if the system is resilient enough, if the platform is resilient enough. But yeah, that's about it. So you do that. Very important point, collect metrics and monitor all the things from the beginning. So when you are doing the first migration of the first component, which is non-critical, already there you should start to think about how do you collect metrics, also from the application, but of course from the platform itself, from the operating system, what the disk is doing, what the networking is doing, what the CPU is doing. Monitoring and metrics, very important for the go live. When you will have issues, this will help you a lot. But also, if you have nice metrics and monitoring in place, it will help you also after the go live. It will help your development team who is doing the operations. It will help your business also to understand what's going on. So if you want to invest your time somewhere, this is the place. Once you have this, you're running the load test, of course. You can check for bottlenecks, stability. You will see immediately when you have good monitoring and metrics if the system is over-provisioned or under-provisioned. It's very easy. You should be verifying correctness of data. Maybe you have some misconfiguration. You're writing into the wrong database. You're writing from production into a staging system or whatever. So you have to run all your jobs, all your manual testing, everything, and to then manually verify that the data and all the wiring is correct. Super important. Security testing, usually very difficult to automate, so you have to do this manually. The new platform is completely different setup from what you had previously, so you have to check everything. You really need to pay attention to security. This is difficult, but before they go live. This is something you have to do. And be ready for a rollback. Plan for a rollback. If you do the thing that we are recommending in the beginning, deploying the same artifact into multiple environments, it will be easier for you to do. But you think about the data. So these are the points. Okay, awesome. I'm now going to give the stage to Matthias to talk about next steps after the migration is done. Thank you.
Thanks. Cool. So yeah, so now you have migrated to Cloud Foundry, but you're still not really done with the migration. So you've done the minimum to get on board and done this hopefully successfully. And now let's see what you can do actually to get the most out of the platform and get fully running on Cloud Foundry. So again, here we will cite the Agile Manifesto to have a continuous attention to technical excellence, because overall this will increase the agility of your team. So what does this mean? So agility for now. Let's have a look at simplifying of the development process. So first of all, if your team is still hosting and operating and own instances for keeping your development team alive, like logging or whatever you need, and you have a look at the services that are provided by Cloud Foundry on whatever cloud you are. Have a deep look what there is and what you can replace and get rid of on your side. So basically everything you operate on your own, fix on your own, this will just take time from your team. So get rid of that, free up your team so that they can get up with working on features and increasing the product quality. So this is one big step. Besides that, you should also aim for automating all the environments. So the development environment, also the deployment should be automated, as well as the testing. So I think nobody really likes doing manual things, especially developers, we don't like it. So whatever you can automate will help you in the past, in the future, and overall, you will for sure take time fixing the pipelines, and it will be a pain. But on the long run, you will definitely benefit from it, from a better product quality, and also your developers will have ultimately more time to focus again on feature delivery and making the product better. At last point, monitor the application. Try to get system metrics and try to find out when your application is first in a healthy state. Then also when it's in an unhealthy state. And if you can, I think this is more a bit more of an advanced topic, also find out when it's getting into an unhealthy state. And this is very, very important, because then you will be able to maybe decrease the amount of downtimes you have. So a really important point, probably takes some time, but if you can achieve it, this is just awesome to avoid downtimes in the end. So the next point we want to talk about is optimizing the application and reducing the cost overall. So first of all, memory in the cloud world is one of the most important parts. So you should first check your application and see if there's any way to optimize the application to use less memory. So this will definitely help you to reduce the cost, and there's normally always something any application can do better. So first of all, we recommend looking into that. Besides that, you should try to aim for scale to zero development infrastructure. So cloud is basically the perfect world for us with the pay-per-use to only use stuff when we really need it. So for example, if you have a testing environment and it's only used a couple of minutes or maybe a few hours per day, why should you not build the testing environment on the fly, do the testing after that, throw it away? So this will definitely help to reduce the cost, because you only pay when you use it. So makes sense. The third part here is, Alon already said it earlier, applying to the 12 factors principles. So again, there's definitely always something each and every application can do better. So we also recommend looking into that, go through the points and see what your application is applying to and what not. So really a good point. And last but not least, I think quite obvious, getting rid of your legacy code and also legacy systems. So if you have legacy pipelines, artifacts, logging, whatever you have, get rid of it, free it up for the team so that they can just focus on the new application. Besides that, we still recommend to maybe keep the old infrastructure in place after the migration for a couple of weeks, just to make sure everything is fine, and then you can throw it away and fully focus on your new journey. Okay, the last part we want to talk about today is the cultural perspective of such a migration. And we will again cite here the Agile Manifesto to build projects around motivated individuals and trust them to get the job done. And trust is really the important word here, because now we have, like, if you have not been on a PaaS before, a unique way to give your team, your developers, more freedom, but also more responsibility. So let's have a look at developer productivity as such. So I think you all know the comparison, IaaS, PaaS, and so on. And overall, hiring and retaining talent is really hard when you are on an IaaS level and you have to deal with a lot of different technologies. You have a big stack you need to take care about, from operations to setting it up, keeping it alive, bug fixing, and patching. So there's a lot to know, and it's really hard to get the right people for the job and also then keep them. So in the PaaS world, this is significantly easier, because now we're really only taking care about the application and the data. So the developers can really focus on that and keep the rest aside. And this will really help you to focus on the development of the application and get the rest out of your team. So besides that, also setting more or betting more on open source will definitely help to maybe not always reinvent the wheel within the team. It's nice, but there's mostly some stuff available you can reuse. So we also recommend doing this at the side. So connected with this topic is the last one we'll be talking about today, to empower a real end-to-end responsibility within your team. Because now is the big time when you're going from IaaS to PaaS, that you really have less stuff to do, and your team can from end to end take over all the tasks. So from development to testing to deploying to operating. This is now all significantly easier when you're on a PaaS level and on Cloud Foundry, and will help you also within the team to organize the team properly. So, for example, as there will probably be less or no silos, because you don't need specialists, for example, for operations, everyone can do everything. So there can be a guy out sick, there can be someone on vacation or leaving the company. You will still have at least 1 or 2 people who at minimum have basic knowledge about the topic. So this is really, really a key thing here when going to PaaS, and you should not miss the opportunity to implement such an end-to-end responsibility in your team and run a real DevOps. So to get the whole thing started, what we did, for example, is when we knew that we want to shift away from IaaS, we involved the team early on and brought them into discussion and talked to them and said, hey, what could be the next step? And in the end, we had the nice solution together with the team, even the team proposing to go to Cloud Foundry. And this was perfect for us, because we had right away from the start the buy-in from the team. They want to go to Cloud Foundry. And this was actually then the start for the team to take over more responsibility, getting involved into everything from A to Z, and getting the whole thing running. And it's also a lot easier now for the team to get information about the project, for example, for project costs. So we also listed that here. So you really see as a team what costs are you producing. So if you are enhancing the product, you can actually see, oh, the costs go down because now we have a scale to zero development environment, for example. So this is really great. So we definitely recommend, if you're going this route, get the team involved and try to get an end-to-end responsibility integrated. Okay, with this, I think we can open up for questions and answers. Thanks a lot for coming.